Hi, my name is Andrew Prokop, and today I want to show you how to use Wit.ai for natural language processing. I will begin by creating a new Wit application. It's important to understand that I am not creating a traditional computer application. I am not writing in Java, Python, or any other traditional programming language. A Wit application is more like a structured database that turns human language queries into actionable data. I will eventually invoke some code to use Wit, but for now I will do all of my work with the Wit console. Let's get started. This application will be used by a fictitious company to respond to custom requests about packages and deliveries. We create an application by clicking on New App. Let's give it a name, Delivery. Optional description, Delivery application. We have a choice of languages. There are quite a few that it supports. We'll take the default of English. We can mark the application as open or private. Open means that all of the data that I create for this application will be open to the entire Wit.ai community, and I'll just leave it that way. And I will say create. Okay. Building an application involves entering a series of sentences that train Wit. Let's start with this one. Will my package arrive today? Wit is going to, Wit will look to see, can I make sense of what was just typed in? Since this is the beginning of an application, we haven't trained it to do anything, so we need to start training it. So I'm going to say, well, let's create an intent for this sentence. The intent is a delivery query. Also, we have today in there. Today can be used as an entity as part of this intent. So will the package arrive today, not yesterday, well that would be silly, or tomorrow or whatever. So let's attach that to one of the built-in Wit entities that happens to be date time. So we have an intent, which is delivery query, and we have a date time, which in this case is today, and I can say validate. Let's go to another question. Let's make this one a little more demonstrative. Send package to Wit Avenue South. So send the package to 10900 Nesbitt Avenue South, Bloomington, Minnesota. Now Wit says, oh, is this a delivery query? Well, it isn't, because really this is a delivery request. So we can create a new intent. We also have some interesting information here. There's two. So we can attach that to another of the built-in Wit entities, which is location. Let's validate this, which means add it into the database. Let's keep going. Let's say, will my package arrive on Thursday? Oh, it's getting smarter. It knows this is a query, and it knows that we have a date time in here. So we can validate this as well. Let's add another one. Send my package tomorrow. Oh, Wit is getting smarter. Realizes this is a delivery request. And it realizes that there's a date time in there, so we can validate this. Now, if this were a real application, I would continue to add sentences that train Wit into the many ways people would ask about deliveries, but this is enough for now. Now, to test Wit applications, I wrote a Python application that accepts human speech, written or spoken, and sends it off to Wit and displays the Wit interpretation. Let's start the application up. The application is fairly simple. Right off the bat, though, I will tell you it needs a server access token. This is, think of it as the programmatic name for the Wit application we just created. In order to find that, we go to the settings of the application. There's a variety of information in here. One of them is the server access token. So I will copy that, bring that over here to my application, put this into my application. So at this point, I can start asking it questions. Will my packet be delivered next week? And I can send that text to Wit. Now Wit comes back with some interesting things. First off, it realizes the intent is a delivery query. It also realizes that we're asking about next week. So it's figured that out for me, and it has some pretty high confidence levels, especially on the date time. It has a good confidence level, almost 80% on the intent. Let's send another one in here. Get rid of this. Let's say send package to my Paris location. Wit comes back and it says, okay, this is a delivery request. And Paris location, even got my misspelling in there, but it realizes that we're talking about a location. So I can use this information in an application to drive that application. Notice that none of the sentences I've added so far were any of the sentences I trained it with. So Wit is smart enough to take the training and move that beyond, that is what natural language processing is all about, move that into really human speech, and then understand, even though I didn't type those exact sentences in, it understands that, you know, what is happening, and it parses it, and it sends me back the actionable items. So, for example, send my package to the moon. And once again, it realizes this is a request, and the value for the location is the moon. This is getting pretty fun, isn't it? This is actually pretty fun to play with. Let's try another one. When can I expect my package? Oh, well, this is interesting. It thinks it's a delivery request. Well, that's not right. So what I would do is I will take that, when can I expect my package? Let's go back to Wit. Let's add this into the sentence. He's going to come back and say that it was a request because that's what it said before. No, this is really a query. And so we can now validate that. Go back to the application. Let's run that query again. Notice how a request is now a query. We've trained Wit to know, to how to properly process this sentence. Now, I've only entered about 5, at the most 6 sentences. For a properly trained application, I would do many, many more, but I think you should be able to see what's happening here. So I train it in Wit, and now outside of Wit, I can start sending these queries down to Wit, and I'm using RESTful Web Services, passing those queries down to Wit and asking it to parse and return back again a structured JSON results that I can use in my application. My application isn't really doing anything with that, but we're going to fix that soon. One of the things I want to point out is I can also send recorded speech down to Wit. So my application will allow you to record your request. So I can say, send my package to Mars, and then Wit will then process that and send that down. So let's actually give that a go right now. What it wants to do is that my application wants to actually put it somewhere, so I'm going to save it in a file. Send my package to Mars. And notice how Wit has responded back with send my package to Mars, so it did a speech to text representation. It knows this is a request, and it knows the value is Mars. That's really pretty cool. Okay, let's make this fun. So hopefully you've seen Breeze. You've seen Breeze, I think, with some of the other videos I produced in terms of how to use Breeze, and then some of the things I've been doing with the Internet of Things, IoT. Breeze is a platform for developing workflows. It has a number of tools that are built into Breeze, like sending emails, sending text messages, all sorts of telephony tools, integration with other services, web services, databases, whatnot. In addition to the IoT tools that I've created, I've also created a tool for natural language processing. So I can drag on to basically the canvas, natural language processing. I can take information, send that off into to Wit, and then process it any which way I want. I can have it come back, and from there I can do RESTful web services calls. I can read from databases, go and take the information, send emails, and connect all this stuff together. Well, I have an application that I've written. And bring that application up. It's not fairly simple, but it does quite a bit actually. This application is triggered or starts on an incoming text message. So a text message arrives. It takes the body of the text message. It sends it off into the natural language processing task, which then in turn invokes Wit and then brings the data back and takes the data back from Wit and makes even more sense than what you saw in the Python application, and then allows you to bring that into a workflow. This application simulates a chicken farmer who has a variety of coops and wants to know what the temperature is like in the various coops, so it can send requests off. You can send text messages into the application. Application will then act upon those text messages. It also invokes some of the IoT tasks that I have. So for gathering information and for controlling the chicken coops themselves. So let's see the application in action. To demonstrate this application, I'm going to mirror my iPhone. I'm going to send messages to my Breeze application, which will then perform the natural language processing. My application is all about weather, but it's really specifically about chicken coops. So I can say, is it hot in coop number 18, where I'm monitoring, where I have an IoT sensor. I can send that off. There's a little bit of a lag. It goes up to my text message relay server. It gets the message, it figures out where the message is destined to go, and then it sends it down to my Breeze server. My Breeze server gets it, processes it, and then sends the answer back. So the delay is actually all in the text message relay server. But I will pause. There we go. Because is it hot in coop number 18? And it came back. The temperature in chicken coop number 18 is 78.17 degrees. Well, that's way too hot. So I can say make it cooler. I will send that off now. Again, it's going through the relay service, so I apologize for the little delay. So the message make it cooler will eventually come down to the Breeze application. The Breeze application again will invoke the natural language processing for my weather, specifically for my chicken coop, and it will send it off into there. Wit will respond back, and it says, okay, I'm lowering the temperature in coop number 18. So let's take this even further. Set thermostat to 78, no, that's too high, to 60 degrees. Now we're sending this off to, again, the relay service. I've said this several times, we'll get it. Add its delay, send it on to Breeze on to natural language processing. natural language processing comes back and it says, oh, I'm adjusting the thermostat in coop number 18 to 60 degrees. So there's a lot of stuff going on here. So I really created a dialogue using a Wit application and then using Breeze to interface with text messaging, to interface in with my IoT tasks, to talk to sensors, control sensors, tell sensors to do things. There are a variety of different questions that I can ask this. I can, get beyond the chicken coops. I can ask it to set the thermostat to a particular degree, temperature at a particular time, or set it between, these hours. I wanted to set it to be, this temperature, or raise the temperature, lower the temperature. Ask it what's going on. But for all intents and purposes, I think I'm having some kind of dialogue with a human being. And that's what natural language processing is all about, is it hides the fact that there's a machine underneath the covers. Oops, that's what happens when I put my phone on the side. So it's hiding the fact that there's a machine under the covers and doing all of this processing. So I've got NLP, I have Breeze, I have integrated in with real live services like text messaging. So anyway, I just wanted to give you a flavor for Wit processing. So the article I wrote for No Jitter about intents and entities, I wanted you to see them in action. I wanted to see how this technology really works, both in the bare bones, again with my Python application, and with a much more sophisticated application to act as a text bot, act as a pseudo-human being, responding and taking action based on the input, which is human language, to from me, a human being, most of the time, and then take action and do the things that I'm requesting to do. Again, so Andrew Prokop, I hope you enjoyed this. Thanks very much for bearing with me. Until next time, take care now. Bye-bye.